Hi everyone. Today in this video I'm going to discuss A levels maths paper 4 variant 2 means mechanics paper of variant 2 October November 2019. So let's start. Okay. Actually, I lost the video of first two questions um, by error. So I'm making this video again. So I'll just explain the first two questions verbally, and then I'll start making the video from the question number 3. Okay, question number 1 is particle is moved in a straight line. The displacement of the particle at time t seconds is s meters, where this is the expression for the s. Find the velocity of the particle at instant when the acceleration is 0. Okay, we need to find the velocity when acceleration is 0. Here is the expression for displacement, and we know the velocity means displacement over time, so we need to differentiate this expression with respect to t. So by differentiating, I will get ds by dt is equal to, this will become 3t square, 12t and 4. Now this can be called v, so v is this is equation number 1. Now I need also acceleration, because I have to put acceleration is equal to 0 for the velocity. So again, acceleration means the velocity by time. So again, I'll differentiate this expression with time. So dv by dt is equal to 60 minus 12. This will become 60 and this will become 12. So this is called A now. Acceleration is 60 minus 12. Since the acceleration is 0, so we'll put this A is 0 here. So this will become 60 minus 12, 0, 60 is equal to 12, and time 2 seconds. So time 2 seconds, at 2 seconds the acceleration was 0. So we need to find velocity at that moment. It means we'll put t is equal to 2 in equation number 1, the expression for the velocity, this one. Okay, so by putting the value t is equal to 2 in velocity expression, I will get v is equal to minus 8 meters per second. This is the answer of question number 1. Question number 2 is, you can see a velocity time graph of a tractor. The graph consists of 4 straight line segments. There are 4 straight line segments. The tractor passes point over time t is equal to with the speed u. This is the starting point of the tractor. It started with velocity u at point O. The tractor accelerates to a speed of v meters per second from here to here. Then in 5 seconds, this one, you need to completely understand this graph first before starting the solution of the question. Over a period of 5 seconds. So this is 5 seconds. In 5 seconds, tractor speed changes from u to v. Then travel at this speed for the further 25 seconds. Then the tractor travels with continuous speed, constant speed for 25 seconds, 25 more seconds. The tractor then accelerates to a speed of 12 meters per second over a period of 5 seconds. So from here, the tractor started accelerating again, and in 5 seconds, the tractor speed becomes 12 meters per second. The tractor then decelerates to rest over a period of 15 seconds. So from here, the tractor started uniform deceleration, and in next 15 minutes at 50th second the tractor comes to rest. So this is the graph. Given that the acceleration of the tractor between t30 to t35 is 0.8, so this acceleration we know this is 0.8 meters per second. Find the value of v. So we need the initial speed. Okay, for this span, acceleration is given, time is 5 seconds, u is v. Actually, don't confuse this v with the final velocity. This is actually an alphabetical v. So I will consider it as initial speed, This is v. We need to find, this is our final speed v, which is 12. This one. So by first equation of motion, v is equal to u plus at, putting the values, and I will get 8 meters per second. This is the answer of the first question, first part. Second part, given also that the total distance covered by the tractor in 50 seconds of motion is 375 meters. Find the value of u. Okay. So I hope everyone knows the distance covered in the speed time graph can be found by finding the area under the curve, the area under the graph. So this highlighted area we need to find for the total distance. If you see closely, there are actually 4 shapes. This is trapezium A, this is trapezium B, this is trapezium C, and this is rectangle B, sorry, this is trapezium C, and this is right angle triangle D. So I need to find all these areas one by one, and then I'll add up these areas at the end. Okay. So total distance covered is equal to area under the graph. In total distance is 375. Area under the graph is area of trapezium A plus area of rectangle B plus area of trapezium C plus area of triangle D. So all these 4 areas. Okay. So the trapezium's area is 1 by 2 into sum of parallel sides into height. These are 2 parallel sides. One is u and one is 8. I found this 8 in the first part. So the height is 5. So it will be 1 over 2 into 8 plus u into 5. And the rectangle is 25 into 8. This is rectangle, 25 into 8. The trapezium C is sum of 2 parallel sides into this height. So this is 8 and this is 12 and height is 5. So 1 by 2 into 8 plus 12 into 5. And the last area of triangle D, this is D. It is 1 by 2 into base into height. Base is 15 and height is 12. So this is 1 by 2 into 15 into 12. So by solving, I'll cut this 5 by 2. This will be 2.5 into 8 plus u. This will be 200. This will be 1 by 2 into 20 into 5. And this will be 1 by 2 into 15 into this 2 will cancel 12 with 6. So 15, 6 are 90. So I'll multiply with 2.5 with this. So 8 into 2.5 is 20 plus 2.5u plus 200 plus 50 plus 90. So take all these terms without u on the left side. So this will become equal to 2.5u. So after solving, it will be 15. So 2.5u is equal to 15. So u is equal to 15 over 2.5, which will be equal to 6 meters per second. This is the answer of question number 2. Question number 3. A particle P of mass 3 kg is held in equilibrium above a horizontal plane by a force of magnitude 5 newtons, acting vertically upwards. Because this force is acting vertically upwards, and the mass of the particle is 0.3 kg, therefore the weight will be 3 newtons acting downwards. So the resultant force will be 2 newton upwards. 5 minus 3 I'll explain later when I'll make the figure. Particle is attached to the 2 strings PA and PB of length 0.9 meters and 1.2 meters respectively. The points A and B lie on the plane at an angle APB is 90. Find the tension in each of these strings. Okay, first of all, I need this angle. I have actually already calculated this angle. How I calculated, I will just explain. If you see, this is a right angle triangle. So if this is our required angle, this will be base and this will be perpendicular. So I can use tan theta is equal to perpendicular over base 1.2 over 0.9. So this will give me theta is equal to tan inverse 1.2 over 0.9, or theta is equal to tan inverse 53.1. This will be this theta. So this angle will be 90 minus 53, which is 36.9. So I got these angles. Okay, for simplicity, I will make another diagram in which the things will be a bit more clear. Okay, let's suppose this is tension A, this is tension B. We need to find the tensions. This angle is 90. Now this force will be 2 newtons. Why? Because this is the resultant force of these two forces. 5 Newton is working upwards, weight is downwards, so resultant will be upward with 2 newtons. Okay. If this is 53.1, this will also be 53.1 because they are corresponding angles. This is 90. So the total angle will be 90 plus 53.1, 143.1. This will be the total angle here. Now, if this is 36.9, this will also be 36.9. So this is 90. So the total angle will be 126.9. So here you can use a couple of approaches like Lamy's theorem, vector diagram. But if you have three forces in equilibrium, then the best strategy is to use the Lamy's theorem. Lamy's theorem is especially for three forces. If three forces are acting on a body and the body is in equilibrium, then the force is proportional to the sine of opposite angle. So, for example, this force will be proportional to the sine 90, 2 over sine 90 is equal to this TA will be proportional to this sine of this bigger angle, this one, sine 126.9, and this TB will be equal to sine 143.1. So this is the Lamy's theorem. All three proportions are equal to each other. So now I will use two pairs for my unknowns. First I will use this one, TA is over sine 126.9 is equal to 2 over sine 90. So take sine 126.9 on other side. TA is equal to 2 over sine 90 multiply sine 126.9. So by using calculator, you will get answer 1.6 newtons. This is the first force. For TB, I will use this pair, the first and the third one. So TB is over sine 143.1 is equal to 2 over sine 90. So TB will be 2 over sine 90 multiply sine 143.1. So when we'll solve this by calculator, I'll get answer 1.2 newtons. So this is the second tension. These are our answers of question number 3. Now, question number 4. A lorry of mass 25,000 kg travels along a straight horizontal road. There is a constant force of 3,000 Newton resisting the motion. Okay. Find the power required to maintain the constant speed of 30 meters per second. So, we know the formula: power is equal to force into velocity. Since the lorry is moving with constant speed, it means there is no resultant force on the lorry. Means the forward force and backward force, resistance force are same. So since lorry is moving with constant speed, therefore there will be no resultant force. Okay, so the forward force is equal to the backward force. So this force will be, therefore F will be 3,000 newtons. Okay, therefore power is equal to F 3,000 into velocity 30. So this will be 9,1,2,3,4 watts. This is the 90,000 watts, or we can write it as 90 kilowatts. This is our answer of part 1. Okay. Now part 2. The lorry comes to a straight hill inclined at 2 degrees to the horizontal. Okay. Now we need to make a diagram. This is the straight hill, which is at 2 degrees to the horizontal. The driver switches off the engine of the lorry at the point A, which is at the foot of the hill. This is our point A. The driver switch off the engine of the lorry. This is point B. Which is point B is further up the hill. The speed of the lorry at A and B are 30 meters per second and 20. So at A the speed is 30 meters per second. At B the speed is 25 meters per second. And the resistance force is still 3,000 newtons. The resistance force is 3,000 newtons. Use the energy method to find the height of B above the level of A. Okay, we need to find this height. this height. Okay. Now, at A, the lorry got some kinetic energy, so there will be initial kinetic energy. Kinetic energy initial means kinetic energy at A is equal to 1 by 2 into mv square. Means 1 by 2, the mass of the lorry is 25,000 kg, and at A the speed is 30, so 30 square. So this will become, after solving it by calculator, 11.2540 joules. This is the kinetic energy at the start of the hill. Now, kinetic energy at point B, here the speed is 25, so the kinetic energy at B will be kinetic energy at B will be 1 by 2 mv square, 1 by 2 into 25,000 into 25 square, because at B the speed is 25. Therefore, by solving it with the calculator, we'll get the kinetic energy at B 78,125,000 joules. This is the kinetic energy. Okay. Now, at B, the lorry got some height, so definitely there will be a potential energy in the lorry as well. So, gain in potential energy at B, this is mgh. So m is 25,000, g is 10, and the height. How can I find this height? This height is actually actually we need to find h, so that's why I'll write h as it is. So into h, which will be 2540 h joules. This is the gain in potential energy at B. Now, the lorry also did some work done against gravity, against resistance, because there is a still 3000 Newton resistive force, so the work done will be against the friction will be W into D. This means 3000 into D, this distance. So there is another thing, work done against friction, that is 3000 into D. This D is the distance from A to B. Now, how can I find this D in terms of H? Because this is hypotenuse, this is perpendicular, so this is a right angle triangle, and from this triangle sine 2 is equal to perpendicular over hypotenuse, so h over d. This is, so take d on the left side, so d will be h over sine 2. So I'll use h over sine 2 instead of d in my expression. So this will be h over sine 2. This can be called written as 3000 h over sine 2. So by dividing 3000 by sine 2, I will get w1961H. This is the work done against the friction. Now you have to be very careful while making this relation. Uh, the lorry got initial kinetic energy at point A. This initial kinetic energy is converted to the final kinetic energy plus gain in potential energy plus work done against friction. So all these three things equal to the initial kinetic energy. So I'll write it as kinetic energy at A is equal to kinetic energy at B plus potential energy at B plus work done against friction. So these three things are equal to the kinetic energy at A. Now put the values. Kinetic energy at A is 1125 4 zeros is equal to kinetic energy at B is 78125 00. Potential energy at B is this one 25. So the gain in potential energy is 250,000 H from here, and the work done against friction is 85961 H. Okay, take this thing on the other side. 1125 zeros minus 78125 is equal to, take H common, 2540 plus 85961 into H. So by subtracting them, I'll get 3437500 is equal to 335,961 by adding them H. So take this on the other side as well. So H is equal to 3437500 over 335,961. So by dividing them, the H will be 10.2 meters. So this is our answer. So that's it. This is the end of video 1, and the next part of the paper I'll discuss in second video. Thanks for watching. See you in the second video.